All right, finally we're on boundary 3. Boundary 3 was the equation 16x plus 16y equals 13. We usually solve for x or y, the easier of the two. There's really no uh, preference here. We'll go ahead and solve for y. Divide through by 16, subtract the x over. You get the opposite of x plus 13 sixteenths. And once again, this is good for x between 0 and 13 sixteenths. So I'm going to substitute this in. F of x comma y is f of x comma negative x plus 13 sixteenths. Substitute that in. I get 8x cubed plus 3y squared minus 12xy. And I'm on that interval. So I take the derivative, set it equal to 0. What do I get for the derivative here? 24x squared plus 6 times this quantity to the first power times the derivative of that gives me a negative 1 minus, I guess I could do product rule if I really wanted to. Yeah, why not? Alright, that looks like a big mess, but let's simplify it down. Because there must have been some reason I chose 16s and 13s. Or maybe I just didn't know what I was doing. Well, let's see what happens here. I get 24x squared minus 6x. Actually, that's a plus 6x. Excuse me, because I had a negative 1 there. I'm going to get minus 6 times 13. That's 60 and 18, 78 over 16. I'm going to get a plus 12x. I'm going to get a minus 12 times 13. So that's 130 and 26. 130 and 26, 156 over 16 plus 12x. So I'm going to get 24x squared. How many x's do I get? 30. And this better work out to something good. I got 78 and 156 over 16. Well, I can divide 4 into each of those. Don't know why I didn't do that. No, I can't. I can do 2. So let's see. That's going to be 36 eighths. Excuse me, not 36. 39 eighths. And that's going to be 78 eighths. Seven eighths. So let's see, that's a 24x squared. And now let's look at the x terms. 6 times negative x times negative 1. So that's a plus 6x plus 12x plus 12x. That's 30x. And now we have the horrible constant term. So if I take 6 times this times negative 1 of negative 6, I can cancel some stuff here partially. I'm going to get negative 39 eighths. And then over here, I'm going to have negative 12 times this, but once again, I can cancel the 2. So I get 6 times 13 over 8. So that's a negative 78 eighths. And oh, look at that. It's negative 11.7 over 8. That must have been why I did that. Okay, so this derivative always exists. We need to set it equal to 0. We can multiply through everything by 8 to make things nice and friendly. And in fact, we can factor a 3 out at the same time. So let's multiply everything through by 8/3. So multiply both sides by 8/3. So 8/3 here, that's going to give me 64x squared. 8/3 here gives me plus 80x. 8/3 here gives me 11.7 over 3, which is negative 39, and that's equal to 0. So this is a quadratic equation. We either try to factor it or we use the quadratic formula. And of course I've rigged it so that in fact it does actually factor. Alright, so here's our quadratic. That's our derivative, setting it equal to 0. And it actually does factor. This is something I torture the intermediate algebra students with. Turns out 8x minus 3 and 8x plus 13 will work. 8 times 8 is 64, 64x squared, negative 3 times positive 13 is negative 39. The all-important middle term, 8 times 13 is 80, plus 24, it's 104. 104 minus 24 is 80, so it actually checks out. And so what do we get out of this nonsense? We get x equals 3/8 and negative 13/8. Now remember, the x's that we care about are between 0 and 13/16. So this one is a keeper, and this one we don't care about. So we go back to our function f of x, and we look at f of 0, f of 13/16, and f of 3/8. Now once again, the f of 0 and the f of 13/16 we really don't have to do. This is boundary 3 that we're working on here. F of 0 is going to give us this number. F of 13/16 is going to give us this number. All we need to do is figure out f of 3/8.